Word Package 6 Video Demo 3. The objective of this demo is to show how Admire Framework provides an holistic vision of the platform and is able to transfer computational resources between two different applications. In this demo, two use cases are going to be executed in the same platform. Use case 1 is Wacom++, a model that simulates the transport of marine pollutants. Use case 2 is remote sensing application that classifies images obtained from satellite and airborne sources in semantic categories. In Wacom++, the number of particles increases over the time, as we can see in this figure. This number of particles is proportional to the application iteration time. The execution time of remote sensing is barely constant. And we assume that Wacom++ has more priority than remote sensing. This means that the goal in this demo is to keep Wacom++ iteration time between 10 and 30 milliseconds. And to achieve this goal, we use first the existing resources in the platform, and if no more resources are available, then we transfer compute nodes from remote sensing to Wacom++. This means that we need to expand Wacom++ and shrink remote sensing application in runtime. Let's begin with the demo by first introducing the layout of the display. So here we can see the number of nodes used by both applications. Total number of nodes, that is 7, broken down by the number of idle nodes, that is 2, which means unused, and allocated nodes, that is 5. This example, remote sensing application used originally 4 nodes and Wacom++ only 1. Here we see the information about the nodes that are being used, the allocated nodes. We can see that this CPU bar is related to Wacom++ that consumes more CPU than remote sensing application. And here is the memory used by both applications. Here we can see the specific nodes used by remote sensing and Wacom++, and as leave here are the 3 terminal outputs of the intelligent controller, remote sensing, and Wacom++. So if we start the demo, what we see is that Wacom++ is creating more and more particles, increasing the application iteration time. Okay, the target is to have a reduced number of times, around 30 milliseconds, which means that the intelligent controller monitors Wacom++ and by means of malleability allocates more resources to it. Now Wacom++ is using 2 compute nodes. You can see there is only 1 idle node, and we are adapting the existing resources to the Wacom++ demands. The next step that will come soon is to assign an extra idle node to Wacom++. We can see here now it's 0. 3 of them are assigned to Wacom++, while keeps the iteration time under the desired threshold. So now comes the thing. I recall that Wacom++ has more priority than remote sensing. That means that given that more particles are created, now the intelligent controller makes the decision of shrink remote sensing by 1 compute node, reducing the number of resources, and assign this compute node to Wacom++. Okay, so what we can see here is that now the size of remote sensing is reduced. Here we see the number of nodes, that is only 3, while Wacom++ uses now 4 different compute nodes. This means that now in this framework, Admire Framework, is possible to coordinate and apply different policies, scheduling policies between different applications by means of malleability. That's all from demo number 3.